Ever since I've watched investigation movies, I have been fascinated with the devices they use for interrogation, especially the lie detector device. When I tried to research on this topic, I got to know that a very simple lie detector circuit could be made using the concepts that we had learned in our Ell101 course. So, greetings everyone, I'm Bhavya, and this is my project for Ell101, which is a lie detector circuit. Before I start off with the main circuits, I would like to reflect upon the concepts which I learned in the classroom, which are used in the lie detector device. The first being the bipolar junction transistor, which is a three-terminal semiconductor device that consists of two p-n junctions and are able to magnify or amplify a signal. It is a current-controlled device. The three terminals of the BJT are the base, the collector, and the emitter. A signal of small amplitude is applied to the base and it is available in the amplified form at the collector of the transistor. The second is the light emitting diode, which is again a semiconductor light source that emits light when current flows through it. Electrons in the semiconductor recombine with the electron holes, releasing energy in the form of photons. The color of this depends upon the energy required by the electrons to cross the band gap of the semiconductor. The third being passive components such as resistors and capacitors. Passive components have an immense role to play in this complex circuit. The combinations of different passive components such as resistors and capacitors make important circuit systems such as voltage dividers and filters, etc. Starting with the circuit diagram for the lie detector circuit, we start off with the very beginning using P3. P3 is the supply voltage and it is connected between 9 volts and the ground. Moving on to the finger pads, these are the places where the person has to place his or her fingers. This lie detector circuit works based on the skin resistant variations. When a person lies during a conversation, his or her anxiety levels rise, which makes them sweat and the hands and fingers become moist and humid. Using this, the lie detector circuit changes the LEDs depending upon the moisture and conductivity of the skin. The LEDs can be turned off and on, which gives the application to it. While dry skin is a resistance of about 1 mega ohm, moist skin has a reduced resistance. Also, when we feel excited or scared, our skin is more moist than usual, and this is the principle which is being used by the finger pads. This circuit determines the low resistance as a lie and a high resistance as a truth. Now moving on to the further components of this circuit, we have a bipolar junction transistors Q3 and Q1 which decide the status of LED diode D2. If it is in on state or off state, it is determined by these two transistors. Secondly, the bipolar junction transistor Q2 decides the status of the LED bulb D1. Again, resistors R5 and R6 form a potential divider in which the value of R6 is subjected to change as the finger pads P1 and P2 are connected across it. So whenever the fingers are placed, the value of voltage across R6 might vary. The variation affects the base voltage of the transistor Q3. The transistors Q3 and Q1 are connected as a Darlington pair. What is a Darlington pair? It is a configuration in a circuit which consists of two bipolar junction transistors with the emitter of one transistor connected to the base of another, such that the current amplified by the first transistor is amplified further by the second one. The collectors of both transistors are connected together. A Darlington pair behaves like a single transistor, meaning that it has effectively one base, one collector, and one emitter. So Q3 and Q1 in this circuit, as shown above, they have the property of behaving like a Darlington pair. Hence, a small variation of the base voltage Q3 will affect Q1. Hence, based on the resistance of the fingers, the transistor Q1 and Q3 will decide either they have to turn off the LED or turn off the LED, and they decide the status of the diode D2. Now, the variable resistor VR1 decides the sensitivity level of the circuit. When the finger skin resistance is very high, Q1 becomes reverse biased and it turns off, And Q2 also doesn't get any bias. The only bias which is taken is by Q3, and it gets that bias due to the Q2 collector terminal unit. And the green LED glows, which represents the truth. Secondly, if the finger skin is moist or wet, then the resistance on the skin becomes very low. Hence, Q1 becomes forward biased and turns on, along with which Q2 also turns on because of the connection they have as shown in the circuit, and because the base terminal is connected with the Q1. And the Q1 transistor emitter, and then the red LED starts to glow, which indicates that this is a lie. This was the basic working on which this circuit functions. The LED diode D2 will only turn on if the transistor Q1 is on. But when the transistor goes on, the voltage of the base of Q2 transistor will be low, thus keeping the LED diode D1 turned off. The base voltage of the transistor Q2 can be controlled by the potentiometer or a variable resistance which is attached at the end of this circuit. So as shown below, this was the working of the lie detector device, which in case a person is lying, shows and turns on the red LED, and if it is telling the truth, based on the skin resistance variations, it shows the green circuit. Thank you.